Two-level factorial experiments is the process of looking at a certain number of variables and testing them at two levels. These levels are usually chosen and defined based on what the data represents or what we as engineers are looking for. An example of this would be pressure between 300 and 500 psi if we define it, and therefore denoting it easier would be 1 and -1. Now, the aim of the experiment is to center in on a few important data points that would need to be further tested and removes any unrelated effects any other data points may have on the set. Now, 2 to the power of p experiments, also known as a full factorial experiment, is where we have the ability to look at all the factors in the data set rather than just a specific few. Each of these factors will have their own levels that are defined beforehand. Because of this, a full factorial experiment is usually done using computer programs because of the necessary processing power. Now in the figure, we can see an example of 2 to the power 4 factorial experiment for the defects in vacuum cleaners. On the side, we can see the number of runs that are calculated. There are 16 runs, and this is usually done because of the factorial 2 to the power 4, which equals 16. Each one of these tables can be referred to as a replicant, meaning a table with a set of complete data with 16 runs is a replicant. Any others would mean another table. Now behind the program, this is the general equation that's being used. Mu is the mean, A, B, and C are the interactions of each other between 1 and -1. A, B, A, C, B, C are the interaction between the two variables respectively between 1 and -1, and A, B, C is the interactions between all the variables together. And epsilon being the random error. We can only get epsilon if we do multiple replicants. Now, one of the ways to apply a full factorial experiment is to test the robustness of a structure or a piece. For my example, I'll be looking at testing the robustness of a robotic arm. Using a full factorial experiment means we can investigate all the parts that go into creating an arm, and while investigating, we should know the impact of each part on the overall robustness of the structure, and what specific parts we may need to look at to further possibly change or reinforce. For most of the factors in the arm, we will use the two very simple levels of bending upwards and downwards based on tension and compression. This is an indication of the material being too weak and therefore cannot hold up the weight of the object, or not being secured in place correctly, causing it to bend upwards due to compression. This can help with deciding what kind of screws, supports, or on the moving joints, and any type of welds we can use on the fixed pieces of the arm. Being able to use a full factorial experiment allows us to quickly and cost-effectively weed out any unwanted observations and look at the more important parts of the arm by not only looking at so many different factors together, but also being able to test them on two levels that are purely uniquely defined for each one. Overall, full factorial experiments are extremely versatile and effective, making them something all engineering students should be familiar with, if not in practice, then in theory. Their application allows us to quickly find what we need early on in the design and testing phase of structures and products so that we as engineers can identify and fix any problems necessary.